Good morning, my dear students. In today's class, in the chapter Kinematics, we are going to discuss uh, numericals on the kinematics graphs here. So if you can recollect in the previous graph, first we started with the basics of graphs, then we went for the numericals on basic graphs. So today's class, I'll go for the problems on the kinematics graphs here. Few more graphs are left over. Let's explore them. So let me start the class. Okay, the topic will be some problems on kinematics of graphs. Okay, there's a ET graph which is shown for us. Already I just drew some graphs, so that will be easy for us to speed up things. Okay, let me read question here. At t equals 0, the body is at rest and at origin. Find the distance covered for first 7 seconds. What type of motion? Like initially it is at rest, it will accelerate for 2 seconds. So what is the distance covered? Will be S02, will write it. Distance covered for first 2 seconds. So that will be 2 half into 2 into 2 square. So this should be 4 meters. Then afterwards, the body will not have, there won't be any acceleration. So it's going to describe an uniform velocity motion. That's what I am showing it here. Then how much of speed it will acquire at the end of 2 seconds? It will be 0 plus 2 into 2, 4 meters per second. Then next for another 3 seconds, it's going to describe an uniform velocity motion. So what is the distance covered? S25 should be equal to V2 into time, B minus 5 minus 3. Speed of the object is 4, 4 into 2, 8, 5 minus 2, sorry, this is 5 minus 2. So this should be 12 meters. It's going to describe a 12-meter distance with uniform velocity motion. Then it will encounter retardation. How much of retardation? -1. So therefore the distance covered will be S57 is equal to 2. Time will be 7 minus 5 minus retardation is 1 by 2, 7 minus 5 whole square. S equal to ut plus half at square formula. 2 into 2 minus 2 square. 4 minus 2, 2 meters. Sorry, this velocity is 4, no? 8 minus 2, 6 meters. So there's an object. First it will undergo, it will describe uniform excited motion, uniform velocity motion, then retarding motion. You can see from the graph. Excited motion, uniform velocity, then retardation. From AT graph like this, we can find out the change in velocity, the area under AT graph should be the change in velocity. That is what we are representing. Now, can we go for correspondingly the position versus time graph? First excited motion, uniform velocity. Okay, this will be the position versus time graph. Let's take another one. At t equals 0, the object is at rest. Let me read the question. At t equals 0, the object is at rest. Find the maximum velocity of the object. What is the motion like? -10. There's acceleration on y-axis. We have acceleration on x-axis time here. So there's a -10, there's a +10. So there. So first the object It is going to move towards left, t equal to 0. How much of acceleration? -10. Then it'll go like this. For what time? For 2 seconds. Let's calculate the distance code for 2 seconds here. S02 should be equal to half into 10 into 2 square. 20 meter it will cover. After this, it's acceleration towards left. After this, it is going to undergo retardation. Then the distance and what is the velocity it will acquire at the end of 2 seconds. I should write this as 10 into 2. 20 meter per second. Then the distance covered from 4 to 2. This should be equal to 20. 2 seconds, 4 minus 2 plus 10 to 4 minus 2 whole square. 20 into 2 plus 5 into 4. 40 plus 20. 60 meter, it is going to move. Is it acceleration or retardation? Actually, something, it should be retardation. Sir, how come you are changing it? Say first the object will move towards left. This will become accelerated motion. This will become retarding motion. So here it has acquired how much of speed? Say 20 meter per second. Then the object will cover a distance of 20 meter. Here the acceleration will be minus. Here the acceleration A2 will be directed in this direction. So because of that, finally the body will come to rest and it will move 20 meter. This part is acceleration. This is retardation. Since the object will first move towards left, no, so therefore this will become acceleration, this will become retardation. Hope I think that little bit some problem comes for students like I said, this is positive, this should be acceleration. No, this will be retardation. If the body is having initial velocity, this will become retardation, this will become acceleration. I think you have to be very careful about some graphs of this kind. Huh? We'll proceed to the next one. Okay, it's asking us to the graph of 1 by v versus x of a particle under motion is as shown. Find the time taken by the particle to move from x equal 4 meter to x equal to 12 meter. Look at the y-axis. We have 1 by v versus x graph. So the area under the graph, what it will signify is what we should think over it. This area under 1 by v versus x graph, what it will give us the information. So let's explore. Velocity is equal to we know velocity is equal to x by t. So can we rewrite this as x by v or further x into 1 by v? And what is x into 1 by v? Should be the area in x versus area of curve, area under curve area under curve x versus 1 by v. So what is this area? Area of trapezium of into 12 minus 4, sum of parallel sides, 0.5 plus 2. 12 minus 4, 8. 5 by 2. 8 for, like a 4, 20 meter, 20 seconds, sorry. The time taken by the particle to move from x equal 4 meter to x equal to 12 meter. Can we calculate average velocity? Distance covered by time taken. So this will be 8 by 20, 2 by 5. We can calculate so many things available here. Just don't get scared. 1 by v versus x comes. Okay, let it be. We can manage. Okay, the next one. V versus S graph. The curve, some information is given. A particle moving along a straight line. A particle moving along a straight line whose velocity displacement graph is as shown. Find the acceleration of particle when displacement is 3 meters. So we know acceleration equal to v dv by ds. What is the velocity of the particle? A3 is asking when displacement is 3 meters, is asking acceleration. This is equal to v dv by ds. So what is the velocity when s equal 3 meters? What is the velocity of the object? It is equal, particle is equal 4. So write it 4. Slope. Okay, this is a tangent. So this should become tan 60. So 4 root 3 meter per second. You should not get anything that one. Suppose, sir, I want the acceleration at this point. Okay, corresponding to some s equal to 5, you should know what is the velocity. Then there you draw a tangent. Then the tan theta has to be substituted here. From that, we'll get the acceleration. Usually we discuss some curve. Here instead of curve, we have a situation of like this. Usually we discuss for straight line. Now a curve, I brought it. For a curve, we need the slope. This is 1 by t versus 1 by v graph. For an object moving along a straight line, 1 by t, t is a time here, so per second. We have to find out the acceleration of the object at point P. Okay, in general, so what is the slope? We have a tangent here. Okay, let's concentrate on the slope. The slope is equal to derivative of 1 by t. dy by dx, we define a slope. So this should be equal to minus 1 by t square dt. So finally, this dv by dt, I can write it as 1 by reciprocal of slope into v square t square. I'm rewriting this one. So what is slope is here tan 30 v square by t square. And look at this sum curve. It will give a relation between 1 by t and 1 by x for at point P. So at point P, 1 by v equal to 1 by t or v equal to t. So therefore, finally, this is the acceleration. dv by dt means acceleration. v equal to t. So therefore a equal to under root 3, negative sign if we are left it. This will be the acceleration. Okay. Find the displacement of particle for last 2 seconds. Okay, look at this one. Find the displacement of particle for last 2 seconds. What we have is v square versus s graph. How do we can proceed here? First, we'll do one thing. Let's write how v square and s are related. For that, we need a slope. So what is the value of slope? We'll calculate. Slope of this curve, this should be equal to, slope should be equal to 1000. Negative slope it is by 2000 by 100 minus 50. The slope is what? I'm getting minus 10. What is this? Similarly, the intercept value, this v naught. At s equals 0, what is that initial velocity? This we don't know, not given. This has to be determined. So already we know slope minus 10. Similarly, with the same thing, I'll proceed here. This will be 200, 2000 minus v naught by 50 minus 0. What is the value of slope? Minus 10. So this everything will become v naught 2500. Now with the help of this, we will write the equations of motion. V square is equal to slope s plus positive intercept. For this curve, this is a curve. For this curve, we are writing the equation, how v square and s are related. For that, we needed a slope. That slope we have calculated. And that intercept is what we have obtained. So this equation. So what is the value of slope? Minus 10. Intercept is 2500. This is similar to v square. Okay, this should be 50 whole square is equal to 2 into minus 5 into s. V square minus u square equal to 2as formula. So from that, if I compare, so what is initial velocity? 50 meter per second, and the retardation is minus 5 meter per second square. The displacement of particle for last 2 seconds. Actually, what do you mean by last 2 seconds? It is going to, it will start from here. It will start with a velocity, then it will undergo retardation. So therefore, let's go for the analysis. V equal to u plus at. For what time it will be in motion? Initial final velocity is 0. Initial velocity 2500. Retardation 10. So it's going to be in motion for, sorry, acceleration 5. Initial velocity 50. So it's going to be in motion for 10 seconds. Body will be in motion for Body will be in motion for 10 seconds. The body will be in motion for 10 seconds. Last 2 seconds. So we'll do one thing. We will go for like this. Distance covered for 0 to 10 seconds. We'll calculate. What is the initial velocity? U 10 plus A 10 square by 2. This will be U is how much? 50, 10 minus 1, 2, 10 square. 500 minus 50. 450 meters. For 10 seconds, it will move 450 meters. Next, for first 8 seconds, how much it will move? U 8. Acceleration is 5 here. 250. I think I'm in a hurry. I'm doing some calculations. Yeah, let's do one thing. This will be 100, 250. This will become 250. Next, for distance covered for first 8 seconds. Okay, this will be again 50, 5 edge of 40, 400 minus 5 by 2. Okay, this will become 40, 64. Okay, 118. Let me keep it here. 400 minus 4 edge are 32. 5 into 32. Or it can be like this, no? 5 edge of 40, 40 into 4, 160. It will come. Now what to do is asking, find the displacement of particle for last 2 seconds, the last 2 seconds. So here like this. Displacement for last 2 seconds will be the difference of these two. How much it will be? 250 minus 240, 10 meters. Okay, this should be our answer. Okay, like this, if they give V square versus S graph, no, you can manage. This is just only writing that equation, first graph, then identifying whether it's a uniform accelerated or variable accelerated motion. If it's a uniform accelerated motion, we are going to take help of the formulas. S equal to ut plus half it square. Then we will proceed here. Okay, after this. Now, which all the graphs possible? I'm writing possible. At a given time, you can see that this is ST graph. First, this will be a uniform velocity motion, object at rest, then again, uniform velocity motion. This graph is possible. This is not possible. The reason for that, at a given time, it cannot have 2 different positions. At a given instant of time, you can see that the particle is having 2 different positions, so not possible. What about this graph? At a given time, this is ST graph. This again time versus position graph. So what is this axis? We will write it time. And this is a position. This is a velocity. For a given time, 2 different positions, not possible. The object cannot have two different positions for a given instant of time. Similarly, for a given instant of time, the object cannot have two different velocities. For a given instant of time, the object cannot have two different velocities, so not possible. VT graph, yes, this is possible. There's no issue with. Able to get this one. So like this, the graphs possible or not is what we should identify. What about this curve? At a given instant of time, it is having two different positions, so not possible. For a vehicle moving along a straight line, suddenly changing its direction of motion, not possible. Okay, now this is for under this condition. Few more conditions, let me bring it. So there's a velocity, there's an acceleration. Is it possible, I'm asking? I think not possible here, no? Though body accelerates, how come this is for object moving along a straight line? Or for body moving along a straight line. Though it accelerates, but the speed remains constant. So not possible. Two-dimensional motion may be possible, but here for motion along a straight line, for body moving along a straight line, this is not possible. Sir, how come? What is the reason? Can you give exactly? Though body accelerates and you're telling the speed remains constant. In uniform velocity motion, acceleration must be zero, but we are saying non-zero here. Cannot occur here, no? Similarly, if the velocity versus and this is an acceleration. This is possible because for uniform acceleration, velocity will keep on increase. This is possible. You have to be very careful about the graphs also. Practically possible or not. Yes, this is also for a body moving along a straight line. First, as the acceleration increases, the velocity of object will increase. Afterwards, acceleration will remain constant and the velocity uniform accelerated motion. So the object is going to move with an increasing speed. This is possible. This is not possible. Here, what you are saying, the velocity remains constant, though it accelerates. Not possible here, no condition. Getting the idea? So you should be in a better position to analyze such motions here. Okay, let's take the the next part is we have to find out the relation between average velocity of a body and the time t as shown in the graph. If during the time interval considered the body did not change direction of motion, draw a graph between instantaneous velocity of the body and the time. Average velocity versus time. We have to calculate the instantaneous velocity versus time graph. That should be plotted. Okay, I think we have to in an accelerated motion, in general, like this much is information is available. Okay, we'll do one thing. I will go back to some basics here. Like in accelerated motion, an object will move. So it is having initial velocity u. After some time, it will acquire a velocity. So this is t equals 0. This is time. So here the velocity, we write it as v equal to u plus at. What is the average velocity for this motion? Already we have discussed. Once again, I'm just, so this should become u plus at dt by t. Solving this, finally we'll end up this as u plus at by 2. So this is an expression for average velocity as a function of time. So let's break up this problem for the time interval t2. The average velocity as a function of time. What is the slope of this 2? If you compare this, what in place of acceleration, what should be there? We have to compare here. So in place of acceleration, we have a 4. Try to correlate. So therefore, for 0 to 1 second, the body is going to describe uniform accelerated motion with an acceleration comparing equations 1 and 2. We'll get acceleration as 4 meters per second square. Then what was the initial velocity? Will be 0. Can we calculate now the instantaneous velocity? V instantaneous should be equal to u plus 80, 0 plus 40. So this should be the curve for t 1 second to 0 seconds. For the interval of time 0 to 1 seconds, the curve will be of this nature. It will increase linearly with the time. Then the average velocity remains constant. If average velocity remains constant means the acceleration must be 0. I'll do one thing. Everything, let me bring it at one place. Yeah. What all we discuss for t equal to 1 second. Okay, that's for interval 0 to 1 second. So for interval 0 to 1 second, we have this much of our data. I'll shade it. So we can plot the graph in the end. Let's analyze the motion. Next, for 1 to 2 seconds, 1 to 2 seconds, average velocity constant. So then what should the instant velocity? Should remain constant as the body moves with a constant speed. If the object moves with a constant speed, then only the instant velocity will remain. Sorry, if a body moves with a uniform velocity, then average velocity, instant velocity will be same. So next, for the interval t, average velocity is 2 meters per second. So therefore the instantaneous velocity also should be 2 meters per second. The last, we have to analyze this part of the curve. First, we'll write the equation of motion for 4 to 2 seconds. This is one discussion. Everything is becoming green. Yeah. And the last part of the interval, we have to discuss the motion for 2 to 4 seconds. Now, what can be the interval? We have to write equations of motion for it. So V average, let's write it here, T less than V average should be equal to 1 plus T by 2. Here, this part, put T equal to 0, so that the intercept should be 1. It will become equal to 1. Put T equal to 2. The average velocity will be 2. The intercept for this. So actually it will come and intersect here. Then put T equal to 4, the average velocity. Put T equal to 4, the average velocity should be 3. Here the 3 is missing. I'll indicate. So you have to extend this curve like this. But it is defined only for, it is defined only for 2 to 4 seconds. Put T equal to 2, the velocity should be 2, average velocity. Put T equal to 4, it should be 3. Okay, I think satisfying this. Don't go for this one. It has to be this one. So if you extend back, the intercept will be 1. And what is the slope of this? The slope of this is in fact how much? 1 by 2. You may get in confusion. I'll write it in this way. Oh, no. Slope is 1 by 2. Intercept is 1. Okay, I have this average velocity in hand. So what equation, if you assume, so that the what equation of initial velocity you assume, so that average velocity will be a function of time of this nature. We have to make a reverse guess of thing. So I'll start with, let initial velocity, let it be 1 plus 2. Let me cross check. Okay, this will be T plus T square by 2 by T. Okay, I think I made a guess. You have to guess it and calculate an average value, then it should satisfy this equation. Okay, now we are in a better position to plot the equivalent graph. Let me bring that graph. Let's we have to plot the equivalent graph looking at those equations. Initial velocity, everything. So that the curve will be first, it will be a straight line. According to this, it will be a straight line. For 0 to 1 second, it will be a straight line. Then 1 to 2 seconds, it will move with a constant speed. Okay, I'll explain it. Let me put it in order, then I'll explain it everything. I have other colors. Let me pick up this. So this will be the 4 meter per second. So this will be 4. This time should be 1, 2, and this is 4 as usual. Compared to that, the 3 will come somewhere here. So this will be maximum, this will be 5, and it will move with uniform velocity with 2 meter per second. Okay, look at now. So these are the, like if they give curve, no, so we can use this method to plot equivalent graphs. This is a very good question. You have this average velocity. From the average velocity, you're plotting instantaneous velocity. Okay, you may encounter numericals of this kind also. The last one. 1 by v versus 1 by f. The graph represents motion of particle moving along the post axis. Find the average speed of the particle during the time interval in which it moves from x equals 0 to x equal to 20 meters. Okay, are you looking at this area? Average velocity is asking. And look at the axis, what we have. 1 by v versus 1 by v versus 1 by x. So first we'll see velocity is what? X by t. T equal to x by v, or x into 1 by v. Area in x versus 1 by v graph. Able to understand x versus 1 by v graph. That is what, and this should be equal to time. Let's calculate, and it's a trapezium, no? Let's go for the area. Okay, this time t is equal to, what is the area? Area of the height of the trapezium. 1 by 3, sum of parallel sides. 10 plus 20. 1 by 2 into 1 by 3 into 30. 5. Then what is the average speed equal to distance covered? 20 by time. 4 meter per second. Like this, we define the average velocity. So several types of graphs you may encounter, and you are supposed to use this method. I think, okay, these are some different varieties of graphs is what I picked up for today's class. Okay, kids, like you have seen the wide varieties of graphs in the kinematics one. So what I suggest is like some math-based problem scheme, somewhere you are supposed to analyze it, and some like you are very familiar. So any of the possible graphs will be you may encounter in exam. So I do suggest like try to explore few more better graphs based on this. So they'll be in a better position. So the same graphs, like I suppose acceleration versus time. In coming chapters, will become force versus time. The same graph, what we have acceleration versus position, will become like a force into position in coming chapters. So it's not that something like a in kinematics what you learned and you're okay, fine, it is there. The overall physics what happened, this graphical analysis will be there. So we'll be in a better position, no? Like, okay, we know some in AT graph, what all we can find out. In acceleration versus position graph, what all we can find out. In velocity versus position graph, what all we can find out. This will be like some sort of basics for us for the total physics. The analysis here. That's why it is given so much of priority. Okay, we'll meet in the next class. Okay, thank you all of you. Take care, bye, see you.